Yeah, as it says, Parametric Equations Part 2. The first couple videos really just introduced parametric equations, what they are, and gave you a couple fairly simple examples, and hopefully by now they are simple examples for you. But I'm going to get into some more, a few more complicated examples and really test your ability here. And we're going to start with an example in which x is equal to e to the t, y is equal to e to the negative t, and t is greater than or equal to 0. So our goal here is to, without our calculators, be able to figure out how to draw the graph of these parametric equations. And we're going to start from the way we have started before, in which we make a t, x, y chart. Okay. And so this should be second nature to you. If you want to graph them by hand, you'd make a t, x, y chart, picking values of t that would be, oops, I don't need that. I tried to use both hands there. Pick values of t that would be convenient. Now, 0 is really the only convenient value, so we're going to run into a little bit of difficulty here. It's kind of a bummer. But when t equals 0, we get e to the 0, which is 1, and e to the 0 also, which is 1. So at least we have 1 point. Okay, let me draw that in a better spot. So we have 1 point for sure, and we know though this is a very important point because that's our starting point. Okay, and our starting point is 1, 1. So that's, oops, what is that? Okay, so 1, 1, that's where we start. Now where do we go from there? Well, e to the 1, we know that that's 2.718, so we can get an idea. And then e to the negative 1, well, what in the world is that? 1 over 2.718, so maybe 1/2, a little less than 1/2. And so then we just start getting into trouble here. 1 over e squared. We don't know exactly what these are. We can estimate, but it's really going to be hard to make a really good estimation. We can try, though. Let's see, 2.718, and then 1/2, so somewhere right around in there. It's getting really tough to do this, okay? And so we need to have a different plan. When things start going like this here, where we're getting random values for x and y, or at least values that we really have a tough time with, then we're going to try a different method, okay? So we're going to come back to this. We're going to exit this screen here, and let's write down what these parametric equations are. X equals e to the t and y equals e to the negative t. Okay, well, one method for actually drawing the graph of parametric equations is to actually eliminate the parameter, and that's what we're going to do here. Eliminate the parameter. Okay, so we're eliminating the parameter t. Let's just make sure we know that. And how do we eliminate the parameter? Well, normally we see y is some function of x. Okay, well here x and y are functions of t. Well, if we get rid of the t, let's take our first equation, let's solve for t, and then substitute it into the other equation. So that's our goal, solve. So step 1, solve for t. And you should write this down. And number 2, in the x equation, because we want y as a function of x. And if that doesn't work out, then find x as a function of y, and then you'll have other challenges there. But solving for t in the x equation, and then substitute into the other equation. Okay, so that's what we're going to do. X equals e to the t. How are we going to solve for t? Well, you have to remember how to solve logarithmic equations. You take the natural log of both sides, or you could just convert this to natural log form. Ln of e to the anything, that's basically like, that goes away. That goes bye-bye. And we get t equals ln of x. So if we get t equals ln of x, wow, well now we have t. That's what t is equal to. And if t is equal to the ln of x, and we substitute that value into the other equation, then look at this. It's pretty cool. So you get y equals e to the negative ln of x. So this goes back to, do you understand, do you remember your logarithmic And exponential rules, well, this minus sign right here, that when we get a constant out in front of the ln, we get to move that constant, right? Remember that? Good. So we get e to the ln of x to the negative what? Well, that's like a negative 1, so we're going to make it negative 1. And what does it mean when we get e to the ln of anything? That's another thing you got to remember. E to the ln, those guys go bye-bye. E to the ln or ln of e, they cancel each other out. And so what we get is just y equals x to the negative 1. Well, I don't like that any more than you do. I like y equals 1 over x. And a quick sketch of y equals 1 over x, we know what y equals 1 over x looks like, don't we? We know it looks like this. Because you remember every function in your cosmic catalog. I know you do. So that's what 1 over x looks like. But remember, when we're graphing, we don't leave it like that. That's not our answer because we're only graphing these parametric equations, again, from when t is greater than or equal to 0. Okay, so these values that we got here in this chart are actually very helpful. Remember the starting point? Starting point? Okay, so what I'm going to do is I'm going to draw the actual graph that we just talked about. The actual graph, remember, looks like this. Okay, but if we're starting at this point right here, if we're starting there, then we can't keep the whole graph. If we start there and then we went to here, this is the rest of the graph. So we basically are crossing off all this stuff, crossing off all that stuff. But that's kind of a big mess. So if you can visualize this, I'm going to erase this stuff, all this stuff here, erasing. And if we start there and we move off to the right, then basically we know that that right there shows direction. That's the part of the curve y equals 1 over x that these parametric equations are illustrating. And that right there is your answer. Okay, that graph right there is your answer. Okay, hopefully that helps. Okay, I'm going to show you one more in, you know what, I'm not going to show you one more. I'm going to ask you to do one on your own, and let's see if you can handle this. Okay, so let's go over here, and in the next video I will show you the solution to this. And let's do this. So we have x, oh, what happened? What happened? X equals t squared. And we have y equals ln of t, t. And then we have, going through puberty, t is greater than 0. Okay, so we have the parametric equations, and you know, this is 8 minutes here, so if you would like, just go ahead and pause the video. I will show you the rest of this in this particular video. Okay, and so I don't want you to watch this part though. I want you to try this on your own, and then once you're done, then play the video. So here we go. Txy. We're seeing that when t is greater than 0. So we have t equals 0, 1, 2. 3, and so forth. Okay, and then we get values of x. X is 0. Oh, t is greater than 0, so we can't take ln of 0, so that goes away. And when t is 1, we get 1 squared. When t is 1, ln of 1 is 0. So we do know we have a starting point. Actually, I take it back. We could go 1/2. And when x is 1/4, oh, so basically it's y equals ln of t. Yeah, so, well, that's kind of tricky, but yeah, I better do this. I better make some more. Let me do this and get rid of these guys. Okay, I didn't want to have you do the whole thing there. If t is 1/10. T is 1/5, 1/2, and then we get to 1, and we get to 2. Maybe we'll throw an e in there. Okay, so 1/10. 1/10 squared is 1 over 100. Okay, 1 over 100. But 1/10, ln of 1/10, that's a really low number. If you think about the graph of ln of x, the graph of ln of x looks like this, right? Actually, it looks more like up here, and then it goes over like that. There's ln of x. And ln of t, that's really what it's going to look like. Okay. Interesting. Very interesting here. Anyway, ln of 1/10 is going to be a really low number. Low number. Oh man.